The components. Multi-pack 1. Resistors. 10 pieces, various resistance values. Resistors are for adjusting the power and voltage in circuits. The unit for the electric resistance is the ohm, short for Greek omega. By putting kilo, 4,000, or mega, 4,000,000, before it, you get the abbreviated names for larger resistance values. For example, 1 kilo ohm equals 1,000 ohms. The value of the resistance is indicated on the resistor in the form of a color code. It is usually 3 colored rings and an additional 4th ring that indicates the tolerance of the resistor. On the back cover of this manual, you will find the entire color code. The abbreviation for a resistor is the letter R. If there are several resistors in a circuit, then a number is added to their symbol, resulting in R1, R2, R3, and so on. Capacitors. A capacitor stores an electrical charge and decouples, that is, prevents the unwanted transfer of electricity between circuit components, since it is impermeable for direct current. However, it allows alternating current to pass through. Its unit of measure is the farad, abbreviated as F. In practice, however, a farad is much too large, since a millionth, billionth, or even trillionth of a farad is usually enough for a given application. These very small units are then referred to as microfarad, UF, nanofarad, NF, and picofarad, PF. In multi-pack 1 in the kit, there are 2 6.8 nanofarad capacitors. Sometimes, however, 6800 picofarad is printed on these. They are the same. Electrolytic capacitors. These capacitors have a large capacity. The unit here is the microfarad, abbreviated backwards UF. The 10 microfarad capacitor, for example, has about 1,470 times the capacity as the 6.8 nanofarad capacitor. Due to the special construction with a so-called electrolyte, the electrolytic capacitor is poled. It is designated with a plus and a minus, so it is important to always pay attention to the polarity when installing it. Warning: installing electrical components with the wrong polarity can cause damage. Germanium diode. Diodes allow the electric current to flow only in one direction and stop it in the other. Diodes are used anywhere that this valve effect is needed. The polarity is designated by the so-called cathode ring. In forward direction, the direction in which the current is allowed to pass through the side with the ring, there has to be more negative potential than at the anode. Germanium is the semiconductor material in this diode, hence the name. A germanium diode offers the advantage that it consumes little voltage. With it, you can build the simple but powerful radio. Caution: never connect the diode directly to the battery. It could burn through. Light-emitting diodes. When current passes through one of these light-emitting diodes, it either emits red or green light, depending on its semiconductor material. Light-emitting diodes are also poled and only allow the current to pass through in one direction. It is therefore important to pay attention to the correct polarity. The short side is the cathode, the long side is the anode. The short side is the cathode with the minus sign. The long side is the anode with the plus sign. A light-emitting diode is also called an LED for short. Caution: never connect an LED directly to a battery. The light-emitting diode will immediately burn out. Always use it with a series resistor of at least 470 ohms. Bag of small components. Push button. The push button, or momentary contact actuator, is used to create a short-term conductive connection between 2 points in a circuit. Using it, one can close an electric circuit and, for example, make a light-emitting diode light up as long as the push button is pressed. When it is released, the connection is interrupted once again. Push buttons are abbreviated as PB in this text. Screws. 3 pieces for the variable capacitor. The variable capacitor is affixed to the console using the 2 short screws. Beforehand, however, the 2 plastic parts there have to be removed from the console, step 1 on page 8. The best way is to twist them until they separate from the plastic console. The long screw is used to attach the rotary knob to the variable capacitor, step 3 on page 8. Variable capacitor. The variable capacitor consists of 2 capacitors of approximately 80 and 150 picofarads. Several insulated metal plates are simply pressed into each other. A variable capacitor is used to adjust resonant circuits and is therefore able, for example, to adjust the reception frequency of a radio. The variable capacitor has 3 terminal leads, 1 for each capacitor and a joint terminal. The terminal leads O, G, and A of the variable capacitor are connected to contact clips A, B, and C located beneath the plug-in panel on the electronics console, step 4 on page 8. 9-volt battery clip. The battery clip is placed into a compartment under the console. Its connections are threaded through and connected to contact clip 404, red positive terminal, and contact clip 804, black negative terminal, step 5 on page 9. Then the clip is connected to a 9-volt battery, and it is ready for operation. Due to its limited shelf life, the 9-volt battery is not included in the kit. Caution: never short-circuit the battery, as it could explode. L module. The L module is a transformer which consists of a coil with 2 windings around an iron core and several terminals, called taps. It is the counterpart to the capacitor, with which it forms a resonant circuit that can be set to a certain frequency. The strength of the coil can be adjusted with a screwdriver. When the iron core is screwed in, the resonant circuit frequency decreases. The resonant circuit frequency can be adjusted in 2 ways, either using the coil or the variable capacitor. Caution: the core is very easy to break, so do not use force to turn it. Earphone. With the aid of a coil and a metallic membrane, the earphone converts electrical signals into audible tones. In this earphone, the coil acts as a sort of electromagnet to vibrate the membrane to produce sound. When we produce sounds or listen to the radio in this kit, we will use earphone. NPN transistor module, 2 pieces. The transistor module has an NPN transistor soldered into the small circuit board that has 4 terminals. Terminal E, emitter, of the transistor, which only has 3 terminals itself, is represented twice. There are only 1 of each of the other 2 terminals, B base and C collector. To put it very simply, imagine that a transistor is an adjustable resistor. The resistor between the collector and emitter terminals can be adjusted using the base terminal. In a way, the base terminal is therefore the control dial that one turns in order to change the resistance. Of course, one doesn't actually turn a knob by hand in this case, but rather by using electric currents. Electronics console, upper console and lower console. Join the upper and lower console pieces together by inserting the 2 caps in the holes on the sides. The caps then form a hinge so that the console can be opened and closed. Insert the contact clips into the many rectangular recesses on the console until they click audibly into place. This area is called the plug-in panel. Please follow the component mounting diagram, step 2 on page 8. The 2 upper rows, contacts 200 to 204 and 300 to 304, are left open. Plastic caps and knob, with 2 caps and knob for variable capacitor. The caps are used to connect the upper and lower console parts. The rotary knob is affixed to the axis of the variable capacitor using the long screw from the bag of small parts. To do this, first turn the variable capacitor completely to the left, then place the knob with the indicator mark pointing to the left onto the variable capacitor and then screw it in. Contact sleeves. The contact sleeves are used to connect the extension wires to the terminals of the light-emitting diodes when you want to install them in the console to the left next to the variable capacitor. One of the terminal leads of a light-emitting diode and 1 extension wire are inserted into 1 contact sleeve. The contact sleeve becomes narrower on the inside and thus clamps the 2 wires together. Then, the wire is bent downward and the light-emitting diode assembly is finished. See step 7 on page 9. Contact clips. The contact clips are used to hold and connect components and wires on the console. They provide physical support and electrically connect the components at the same time. The contact clips are inserted into the rectangular recesses of the experiment console until they click audibly into place. Please follow the component mounting diagram, step 2 on page 8. The two upper rows, contacts 200 to 204 and 300 to 304, are left open. Short jumper wires. The short jumper wires have to be bent so that they measure 15 millimeters. Step 8 on page 9. They make the electrical connections between the individual contact clips. Long jumper wires. The long jumper wires have to be bent so that they measure 30 millimeters. Step 8 on page 9. They make the electrical connections between the individual contact clips. Wire pieces. The already bent jumper wires are not enough for some experiments. Longer pieces of wire are additionally needed. For connecting the light-emitting diodes as well, when they are to be mounted in the console, they are needed to extend the connectors. Instruction Manual for Electronics Workshop 1. Instruction Manual. Instruction Manual for Electronics Workshop 1.